Hi everyone, this video is an exercise 11I question 5. So we have y is equal to x root 2 minus x, and we want to use this equation to complete the table. So we just need to substitute x, which is as 1.5, so y is equal to 1.5 times 2 minus 1.5, and we'll get 1.0607 for the value of y. So that's part A. Now we're given that I is equal to this interval, and in part B we want to use the trapezium rule with 4 strips to find an approximate value for I, and the answer is in 4 significant figures. Right, so as always, whenever we want to use the trapezium by root formula, so that's the formula. Essentially, we first find the value of h, which is b minus a over n. So in this case, b is just the upper limit and a is the lower limit divided by the number of strips, which is in this case 4. So we get a half, and then we just plug in the values into the formula. So the formula is half h, and then the first and the last y's, plus 2 times the sum of all the y's in between of the first and last one. So that means we'll have this integral essentially. So I is approximately h over 2, so y is 0, plus 2 times y1 plus y2 plus y3 plus y4. And now, so for h we know that h is a half, and then half divided by 2 is 1 over 4. And here we just substitute the values, so we have 0 plus 2 times 0.6124 plus 1 plus 1.0607 plus 0. And yeah, so that's basically what we have, and then we just find this 4 significant figures, which is 1.337. In part B, in part C, we want to use an appropriate substitution to solve this basically. So, and the answer has to be in the form 2 to the power of q times p, where p and q are rational constants. Okay, a natural substitution is just setting u equal to 2 minus x, because that's what we normally do when we have a square root. And that means du by dx is just minus 1, which means du is minus dx, therefore dx is minus du. So now that we have this, we can also rearrange this part, and this gives us x is equal to 2 minus u. So now we can substitute this into the integral. So also we need to transform the limits. So when x is equal to 0, then we substitute that here. 2 minus 0 is 2, so u becomes 2. And when when x is equal to 2, then u becomes 0. So x is 2 minus u, and then root 2 minus x is just root u, and dx becomes minus du. Remember, this minus is multiplication. It's going to be multiplied by the entire thing. And one interesting point here is that basically we can basically swap the limits, so which means 2 goes up and 0 down, and then we add a negative to the integral. So essentially we will have double negative. So we already have this negative, and then we times everything by another negative, which means the whole effect becomes positive. So we'll have this integral basically, which is 2u to the power of half minus u to the power of 3 over 2 du. So we just integrate them, and the first term becomes basically 2 over divided by 3 over 2 u to the power of 3 over 2, and the second term is minus 1 divided by 5 over 2, and then u to the power of 5 over 2, and then we add this. So we just substitute, and after that we'll get 8 over 15 2 to the power of 3 over 2. Okay, right. And finally, for the last part, we just calculate the percentage error of the approximation in part B. So essentially, what we do is that we just use the exact value and the approximation, and just we find the difference times by well, divided by the approximation, and we divide by the exact value basically. So the person so the percentage is basically, so in this case we'll find the difference between the two values we had. So 1.5085, this is the exact value, so this value that we found from the analytical integration, and then the numerical value from the trapezium rule, and we divide that again by the exact value. So it gives us 11.4%. So that's the error.